Representation of bitmap images. So images are all stored as binary code, and a pixel is made up of two words, picture and element, and that's how we kind of define the smallest part of a picture. So a picture is made up of these little tiny cells called pixels, little tiny squares almost, on your screen. Image size and resolution, usually written as two numbers, so 640 over 480 is the dimension. So the first number is the width and the second one is the height. In a bitmap image, a 0 is represented as black and a 1 as white. So if we look at the one on the left, you've got a series of 1s and 0s, and if you really squint you can see the outline of a H, and then on the right that's clearer. So I've changed all these 0s to black now, just to show it. But the one on the left is how it would be stored. So our 0s are there, highlighted in yellow. Image quality is linked to the number of pixels. More pixels equals more detail. So in our bottom image, where we've got 16 by 9 pixels, we've only got 16 in a horizontal row to kind of display this eye. Where at the top we've got 192 by 108 pixels, we've got a lot more pixels to add detail, because each pixel can be a slightly different colour to create the illusion of this image. The number of bits per pixel determines the number of possible colours. So remember, a bit is a 0 or 1. So the number of bits we're using per pixel is how many different colours we can represent. It increases the amount of unique colours the image can use. Let's have a look at that. If you use 24-bit or true colour displays, basically blue has got a byte, green has got a byte, and red has got a byte. And it's a combination of blue, green and red that create the shades of colour. So 24-bit means we've got a lot of 0s and 1s to basically store the colours that we need. So for example, one colour could be made up of a collection of red, which might be 11010101, green set at 255, and blue as 192. When they are combined together, when you mix that red, green and blue together, that creates the colour we want. Now often in programs like Photoshop, it's really hard to remember the binary for that 24-bit number. So what we do is that's where the hexadecimal comes in. So the hexadecimal value is a 6 character number, I suppose, made up of 3 different bits of hexadecimal. So the first bit, 66, would be the hexadecimal for the red, 99 would be the hexadecimal for the green, and the CC would be hexadecimal for the blue. Or it might be RGB, it might be the other way around, but that's the idea. So not all images are just black and white then. So we're going to need more than one bit to represent a colour in each pixel. So let's say we use 2 bits. 2 bits will generate 4 colours. 4 bits will generate 15 colours. So if we look at this, we've got a very scaled down version of, let's say, the American flag. We've got red, white, blue and black. The black around the outside would be set to 0, 0. The reds are all set to 1, 1. The whites are set to 1, 0, and the blues are set to 0, 1. So that allows us for 4 colours, but we're only using 2 bits. So it's only 2. Think about it, there's just combinations of 0s and 1s. How many different combinations of 0 and 1 can we make if we've got 2 of them? Well, we can have 0 and 0, 0 and 1, 1 and 0, and 1, 1. So it's the maximum number of combinations you can make with that bit that give you the colours. So looking at these 2 images, which one is the bigger file? Which one takes up more space? Is it A or B? Now if you think about it, each pixel has so many bits allocated to it. If it's a 1-bit image, we just generate white and black. So A, we can see, is a 1-bit image. You only need a 0 or a 1 to represent each of those pixels on there. However, B has got different shades. So there's 4 shades of either grey, black or white on there. So we'd need at least 2 bits. So it must be a bigger image. Not because it's physically bigger and it's got more pixels on it, but just because more colours are on it. So here we have a standard question where it tells us about resolution. So James has a 10 by 10 inch photograph with a resolution of 60 dots per inch. Resolution isn't about the quality of the image. Resolution in computer science is just referring to how many dots per inch there are. Now in a question they'll usually give you how many dots per inch and the measurements of the picture. So 60 dpi. So 60 dots per inch. In 1 square then, there are 60 dots per inch. So to calculate the resolution, first of all we need to find the area squared. So we need to find the area of that square. So 60 times 60, or 6 times 6 and then add 2 zeros on the ends, gives us 3,600 dots per inch. If we know how many dots are in 1 inch, we just then times it by the measurements they've given us, such as a length of 10 and a width of 10. In which case, here we just add 2 more zeros on the end. So they'll always give you a dots per inch. So this could say this image has a 40 dpi and it measures 10 centimeters by 20 centimeters. But they'll probably do it 10 by 10 for maths for ease. First of all, work out the area of 1 inch and then times that by the length and the width. Metadata. If an image is stored as binary, how does the computer know it's an image? It's just the zeros and ones. So for the computer to be able to remake that image on your computer or anyone else's computer, it needs to know certain things. And metadata is information about the image, such as the color depth, the image height and the image width. If the computer knows the color depth, so how many zeros and ones are being used for a color, the image height and the image width, it can recreate any picture. So let's try and work through this example so you can see what's going on. Basically, the computer's trying to sort out what to do with all these zeros and ones. And if it doesn't know how high the image is, when does it know when to stop? And if it doesn't know how wide it is, how does it know when to stop printing it at the width? And if it doesn't know how many colours are being used, is it a black and white image? What colours are available to it? That's like saying paint a picture and you can only use 2 colours, or you can use every colour you can find. The computer needs to know that before it can build the image. So let's take this string here, 0, 1, 1, 0, 1, 1, 1, 0. That's just a string of zeros and ones. If we say it's a 2 by 2 image, then in the blue box, I've now split this to make an image that is 2 by 2. And the yellow box shows how, if it's got a color depth of 2 bits, so we can only ever have 4 possible colors, that's how it could be laid out. First pixel could be 0, 1, the one next to that could be 1, 0, then on the next line the first pixel could be 1, 1, and the one next to that is 1, 0. So metadata is just simply information about the picture, and it always contains the width, the height and the color depth of the image. It may contain some more information, such as the camera that was used, or where even on Apple phones it will show you the location where the photograph was taken. But for GCSE, in the answer, width, height and color depth.